Hello friends, welcome to the ETC Guitar YouTube channel. We're back here with the 1968 Fender Princeton, and we're gearing up to do some of the last work, mainly the 3-prong, replacing the rest of the filter caps, and then double checking the bias circuit is correct, firing her up and seeing if there's anything else that's needed. And I was just looking over the amplifier and I noticed, if you can see this right here, that the heater connection was basically looked like there's a clear hole there. So I just kind of pulled the wire and it easily slipped right out of the connection there. If I can focus it, you can see the hole there. So yeah, this was like that from the factory. This amp's never been touched before until I worked on it. So yeah, just old solder joint failed there. So let's go ahead and reattach this with some nice fresh solder. And then we'll go ahead and move forward with the rest of the work, which includes removing the 2-prong here. And I've already started moving around the wires and whatnot for the 3-prong, but one bite at a time. Well, we've got ourselves a roadblock here. So I went ahead and just did what I always do. You can see I moved all of the stock wires here and just made them loop around themselves on the ground switch, so it's out of circuit. Same with the death cap. It can stay there because it's out of circuit and they're out of the way. I removed the solder here from the fuse tip. I made the connection from the fuse sleeve to the switch where the primary of the power transformer is. The other one, this one will connect to the neutral, and we'll be doing that here at the courtesy outlet. But there's a major issue here, and I've never run into this before. The actual hole, let me focus it, is extremely small. And I did notice this, but I didn't honestly think it would be that big of a deal. I've worked on many vintage Fenders, and I've never worked on one that had a hole this small. The strain relief is absolutely miniature. I'll compare it to a more normal sized one. This is what I typically use. So you can see the size difference there. So significantly smaller. And obviously that's not even going to come close to fitting. And this is far too small to fit the 3-prong in. And so grab that just to show what I mean here. So the 3-prong with the insulation is, you know, borderline too big as it is. And no hope of ever getting the strain relief around the 3-prong with the insulation. But even I tried, you can see the indent right there. I tried putting the strain relief, the stock one, around these 3 wires just grouped together just to see if that was even possible. And it's not even close to closing with those 3 around the strain relief. So yeah, and this is 16 gauge, I believe. Just a pretty standard 3-prong I purchased off of Tubes and More. And let's see, it should say on it actually. Yep, 16 gauge. So the only thing I think of is maybe trying 18 gauge. And seeing if that is small enough. I'm honestly not sure. So I'm going to ask around and see if anybody knows offhand or has worked on, you know, one of these. Again, I've never seen this before in a vintage Fender. Every one I've ever worked on used the standard size here. So very interesting and kind of an unforeseen piece, little roadblock there. So with that, unfortunately, we're not going to be able to do the 3-prong tonight. So we'll just shift our focus back over to recapping the amplifier. So we'll take care of all of the remaining electrolytics here, and here. And we'll just have to wait for the order to come in to continue. So let's get to it, salvage the night here, and at least wrap up what we can and move on. All right. Our main focus will be this 25 microfarad cap, this 25 microfarad cap, and this 25 microfarad cap. So these are the cathode bypass caps for the preamp section here. And I showed actually in a recent video me working on my 1955 Magnatone 108 Varsity. And that amplifier, I experimented with changing the value of the cathode bypass cap. And you'll see it had a pretty significant dramatic change in tone when I went from various values. But Fender's pretty typically stuck to the 25 microfarad value. So that's what we will be swapping in here. So we got 1, 2, 3. And this is probably the easiest amp to recap with the cathode bypass caps because you don't have any doubles. These are all individual singles. You'll see in other amps where you have to actually tie the ground connections of 2 caps together to get them in one eyelet, but this will be nice and easy and a change of pace. So let's just go ahead and work on removing the stock ones here. Just like we always do, we'll add a little bit of solder, get things flowing, and then pull them up. So we'll just go ahead and clean the tip a little bit, add some solder, and then we'll grab our dental pick here. I just like to just get it to flow a little bit. We'll do it to both sides here. And then we can just go ahead and pop both out, honestly. Oh, now here's something I forgot again. And I mentioned this before, but I always forget with these Fenders. This lead right here, see that? And this one right here, I believe that should be the actual lead off of this cap. That should be the continuation of the cap. Now, it's a little confusing because this one right here, there's no cap for that to be the continuation of, unless this is a continuation. Well, let's see. Now it's going to this eyelet. So I'm not exactly sure. There's a chance it might not be. So instead, let's go ahead and remove the solder and see what's hidden underneath. I've never worked on a non-reverb Princeton before, and it's already got a lot of differences. And yep, there you go. So you can see, I've also never worked on a, actually, no, I have worked on a transition era Silverface. But you can see right here that this lead, hopefully you can see that. Let's try and zoom in a little bit. Move it down for you guys. All right. So hopefully you can see it right there. That is the tip of this ground lead bent over here. So in fact, this is not the lead going through there. It has its own wire. That is a different methodology than what they used in the blackface era, and maybe even the same era, but just different models. That could be something that's specific just to this model. Not really sure, but we'll just pop that up and out of the way. And then this one should also pop out, no problem. And it does. All right, so now we can go ahead and try and clean off some of this solder. And clean out the eyelet, and we'll just rinse, repeat. I'll skip ahead here because that's kind of boring to watch, but the process is pretty straightforward. And we'll get to the install now. Been a bit of a delay since I last worked on this amplifier. Unfortunately, I broke my soldering iron. It was on me. The base is fine, but the actual iron itself broke, the internals. So as a result, I had to order a new one, and it took a while to get here. But I'm back up and running now, so we're going back to this amp and just kind of wrapping things up to be able to turn it on, and we'll be able to do more work to it after it's turned on, be able to confirm the bias and all sorts of things like that. But we need to get the power to it, so we're wiring the 3-prong in. I've got the neutral here going to the courtesy outlet, which is then got the other end of the primary for the power transformer. So let's go ahead and solder this connection real quick, and then we'll move on to the next one. Here we now have the hot wire all done. So let's go to the fuse tip. We're just using this as a junction to make it shorter and retain the functionality of the courtesy outlet. Neutral, same thing, going to the connection here. And this is one end of the primary. The other end of the primary is connected to the switch, which is then connected to the fuse sleeve and the fuse tip, so on and so forth. I've actually got a video on the channel detailing all of this in much more detail, but we're going to go ahead and move on to the ground connection here to the chassis. So it's going to be something along those lines over here. And we don't have to keep this quite as long because we cut these really short, but you always want the ground wire to be the longest of the three. So let's just go ahead and flip the amp over. Actually, no, it'll be easier for me to do it from this side. So we'll just move some wires out of the way and get this ready to go with the big iron. So the first thing I'm going to do is just go ahead and decide how long I want this to be. So we'll probably cut it about there. Grab this. We don't need it to be too long, not too short. That should be fine. And then we'll kind of just have it basically right here. So with that in mind, we're going to go ahead and score the chassis here. I like to use just a basic flathead like this. Do a little cross pattern, a little hash pattern in the metal here, just to make sure there's plenty for the solder to grip onto on the chassis. We'll add some solder, then we'll add in the wire, and we should be good to go. Fairly straightforward, though this is, I maintain the fact that this is really the hardest, in my opinion, part of doing a 3-prong swap, and definitely takes some time. Now this is a very thin gauge wire versus what I normally use is 18 gauge, which is what we had to use to be able to fit into the grommet here without drilling into the chassis. But it is quite a bit smaller than I'm used to. So, and it does seem like this insulation melts really quickly. So this might be a bit trickier than normal, but we'll be okay. For this, I like to use the bigger gauge solder here. This is 1.5 mil. Just to get ourselves a little blob like that. And then we'll go ahead and flip the chassis around so it's better position for me, because I don't want to accidentally melt any wire here. So let's go ahead and flip it around. All right, now we want to be so careful not to hit anything here. It's really easy to do. So we're going to try and just heat up the solder again, and then we'll push down on the lead here. Just try and get it. There we go, just like that. And then now that that's kind of together, we can just go ahead and touch it real quick. Perfect. With a solid chassis ground. And we should be good to fire it up now. And then we can start setting the bias and doing all that other fun stuff. Well, I say ready to start it up. In theory, we still have some more stuff to do. The cathode bypass caps still need to be installed. And I need to go through my notes and see what else is left. But we're getting very close to being able to fire it up. And maybe even tonight. So, cool. Let's continue on. Skipping ahead a little bit, I installed the cathode bypass caps here, 25 microfarad, 50 volt mods. The resistors we identified were out of tolerance, but we will keep them for now. There are other resistors we also noted that were out of tolerance. If you remember, I believe it was this 220K, both of these 220Ks. These ones are most likely going to get replaced regardless, to be determined with these ones over here. But now that we've got it hooked up, with a 3-prong and all of that, we can fire it up finally. So I've actually already done my initial test with the current limiter here and confirmed there was no issue. So now we're going to go ahead and turn it on full power straight from the wall. I've got my signal generator going into the front here. But the first thing I want to do really is just check the bias. So that's going to be kind of goal number 1 here. I've got the bias probe in it right now. And let's go ahead and turn that down. So let's go ahead and flip it on and see what we're getting here. So negative bias voltage, their schematic does not say what is expected there, but looks like we're getting at the coldest setting negative 47 volts, which is quite cold. So I'm not surprised by that. This is going to be a very cold bias, but we want to start the coldest possible and then work our way up. So using the Robinette calculator here. Let it warm up for a second, but just to give an example, so we're now at about 25% plate dissipation. So very, very cool. And that hopefully means that we've got enough room going up to be able to warm it up without overdoing it. So let's kind of see what we're working with here. Go ahead and turn this. My hand blocks it. There you go. And you'll notice that the numbers are changing here. So let's go halfway, roughly. See what that gives us. It's still gonna be cool, but let's see what we're at. So 419 for the plate voltage. The current, it's like 13 milliamps. So that brought us up to about 40%. So still a bit cool. Now Princetons are a bit, it's a bit different biasing these because the tremolo is affected by the bias. So you can set the bias just kind of based off the numbers here, but really you got to listen to it and hear the tremolo, because at some point the tremolo will not be working properly. And I guess it's possible that the bias range could be something you might want, but the trem just won't work really anymore. So you got to be cognizant of that. So that gives us about 50%. So it looks like we might have to change this resistor after all. This is the stock value resistor. So this is the warmest it'll go. So that puts us right at 54%. So completely safe, but we don't really have a ton of headroom to go warmer. So we will be changing that resistor. So right now in its current setup, this is a this is a 22K, right? Red times 1,000. Yeah, 22K. So we'll probably want to swap in, I don't know, 15K, something like that there. I'll have to see what I have, but regardless, we can go ahead and just confirm it works like this. So let's just go ahead and give it a little volume. Cool. Seems to be working fine. No scratchiness on the pots. Volume, the bass and treble both seem to be fine, and the tremolo is working. Sounds nice and deep all the way up. And speed seems normal, so everything seems okay from that side. So really just got to dial in the bias, which is no big deal, but seeming pretty healthy. And then all these other components here, we'll have to play. Obviously, it's a bit too late right now. However, we will just, I'm 99% sure I'm going to replace these two right here. This is part of the phase inverter circuit. Really important. These are closely matched, and they're not closely matched at all right now. So replacing those with two that are. And then this one's pretty far out as well. Oh, there's a lot of resistors that were out on this amplifier. But to the point of several comments in the last video of this series, sometimes that results in a cool sound that's a bit different than the original, which might make the amp sound even better, depending on what your preferences are. So we'll keep that in mind. But without hearing it for myself, I'm just kind of guessing. So maybe we'll do that in the next episode, if you will, of this series, where we'll kind of test out, do some Mythbuster pieces on that. So anyways, we're going to go ahead and stop here, pick it up tomorrow, and continue on with this project. Thanks so much for watching. Until next time, see ya.